to do. I'm from Cuba, by the way. There is no NFL in Cuba. I came to this country 20 years ago, and so far, so good. So how that our league works? So you pick your teams. That's basically how it works. You pick your teams that you want as a winner. You rank them. That's the weight that you put. If you happen to hit the winner, you accumulate those points. If Philadelphia, for instance, doesn't win this week, those 15 points is down the toilet. They don't matter for you. So every week, that's the idea. And Amit and I decided 2 years ago, say, maybe there is a better way to do this. Like, let's be smart about this, because it's Amit's whole family running the league. And the idea is like, it's always, not only for the sake of like, getting some points, but hey, we beat you, because we get to meet those guys all the time. The betting world, this is interesting. The betting world already provides you a view of the world. So the spreads, if you think about it, the spreads that Vegas give you is like the benchmark as to what the world thinks about the games. A simple strategy would be to rank the choices each week by the spread. So you take your winners, you take the spread, you rank it from the higher spread to lower spread, and you pick the winners that way. There are some other ways to rank the winners by means of like win-loss records, basically the opponent's strength, their home and away, division, non-division games, whatever Peter King decides to say, oh, these are the winners, I don't know, you pick some pundit, doesn't matter. But ideally, the point spread should encapsulate all this information. Now the question is, how good is the spread strategy? Well, in 2008, the simple spread strategy would have lost by 6 points. So in 2008, as you can see, Amit was the winner. And the spread strategy would have been like right in second place. We consider the winners, if you finish on the 3, finishing in the money. Finishing in the money means the top 3. On average, the spread strategy would have won in about half the years. A little bit less than that. It is important to remember that this strategy requires no thinking. You take the spread, you sort them, you pick the teams, let's go. There is no thinking involved. You don't have to, okay, well, who's the winner? Who is injured? Doesn't matter. Pick the winners straight from the spread. For instance, this is for the last, since 2008, the winning score this is the score. Picking the spread, this has been the score. So 2 years they have been the winner. The other years, this you have been pretty close to the top. I will show you the state of the game today. The first place, the difference between the first place and second place, around 15 points. So anything below 15 points would have get you in the money. And that's be good enough for you. So the question is now, can we do better? Or can we win every year? That's what we're trying to prove. So, you want to take over or? Go ahead. All right. So what's the idea? The idea would be, we tried to figure out a quick method. So we were on the crunch time last summer. So what we do, let's do something better. Say we can use simple linear regression, right? So you take a line and then from there we do some little prediction, forget about the error. Let's go for it. We were thinking maybe no. Well, let's go even further. Let's try logistic regression. So as you know, logistic regression is used to classify data into in 2 or more different groups. And for simple cases, that boundary is very easy to delimit. So you can delimit your boundaries very straightforward. And sometimes there is no need for a line. It's not supposed to be a completely linear boundary. It could be could be a curve around the boundary. The whole idea, since it's easy for us, since we're using a logistic regression function for a classifier, it's very easy for us to give you the probability when we rank the teams. And that probability, we can use that probability as will be our probability of picking up winners in our pool. Since the goal is predict a binary outcome, so basically wins and losses, it makes sense to use this specific algorithm since I get a probability right out of the bat. All right. The most simple one will be just get a set of features, so the characteristics that we want to fit to the machine learning algorithms, and get an output that says basically if you're going to be a winner or not. That's pretty much. So we got together, so let's think about which features we're going to use. So we need to determine what are those relevant features. And we need to think about what the classifier, what exactly am I going to be predicting? For that, we're going to use Python. We're going to have a little Python notebook to show you. We use a scikit-learn as our main library to work. So we wrote this little program that we're going to make available to the rest of the world today. Then we have a little notebook. This is very unsophisticated. a little notebook that picks the games for us. And then we did right away some back testing. Then we're also big cycling fans. And we have 3 strategies. We have our Merck, Hinola, and Durain. If you know about bicycles or cycling races, you probably know who those guys are. We figured out, so which is the best strategy? We tried 3 different, using logistic regression, 3 different outcomes to what to pick. You want to take over this?
So this is the one that we. Right. Yeah. Thanks. So the spread strategy is the one that we talked about, where you don't use your brain and you just pick according to the spreads. The 3. We'll go into the details of the machine learning algorithm, but basically the first strategy, the Merck strategy, is where you still pick the favored team at all times, but you rank by the probability that the machine learning algorithm spits out. The second case would be you pick the predicted team, because if the probability that the team is going to win is less than 0.5, that actually means that you're predicting that the underdog is now going to win. So this is like one strategy to start picking the underdog instead of the favored team at all times. And then you still have to decide how you're going to rank this. And so the third strategy is to not only pick the team that the learning algorithm picks out, but also to rank by, like let's say a team was ranked as 0% probability of winning. That means that the underdog has a 100% chance of winning, in which case you should probably rank them the highest, 16, instead of the lowest, which is like 1. So, in reality, the third strategy makes the most sense, like it fits the physical description of the problem. But in the end, we still wanted to win the league, and we wanted to do what seemed like the most reasonable thing to do. And it turns out that the strategy has like a higher average, performance, as well as a smaller standard deviation. So we decided to go with the second strategy to see how we would do. So we'll go into like how we're doing this season. And so let me switch to the notebook now. See if I can find that guy. How do I make this guy? Green button? Is that good? Full screen? Is that good? It's very, all right, good enough. All right, so here's our IPython notebook where we kind of go through the code here. Our source of historical data is actually very simple. A lot of people have asked like why we didn't incorporate other data like weather at time of game temperature, whether it's on grass or turf, or, whether Green Bay is playing inside or outside, all of these things. So we didn't go into any of that stuff. It's a very simple data set. It's just the historical outcomes of the games and what the spread was going into the game. And, there's a lot of places for it. This is the place where we got the data. So, the beginning of the Python notebook is pretty standard stuff. You're, setting up your paths. You're telling it where to find, various, like the lookup data. We need to know, what the season outcomes were. We need to know what divisions the different teams are. Even little things like, names of the teams and stuff like that. So here's like a little snippet of the teams. So here's where we start getting into the nitty-gritty in terms of what are we using to actually do our classification, right? So our features are the record of the favored team, the record of the underdog, so where it says previous favored and previous underdog, that's last season's records. That might be useful when it's early in the season, nobody's played each other, but probably last year's Super Bowl winner has a better chance of winning than a team that was 0-16 last year. And then as the season progresses, you would imagine that the previous season's record becomes less and less important, and the current season record becomes more and more important. Game week is like which week are we in the season. It turns out, we'll show this a little bit later, I thought this was going to be a very useful feature because, let's say you're 1-0. That's a 100% winning percentage. Or let's say you're 10-0. That's also a 100% winning percentage. And it seems like a 10-0 should be more meaningful. So I thought that the game week would be like this, factor or feature in the algorithm that would sort of highlight the fact that teams were, good teams were doing better. But it turns out that the actual score that it gives this coefficient is, not very good or close to 0. So it seems to have marginal value, but maybe it's because some of the information that it encapsulates might already be sort of incorporated into some of the other factors. The absolute line is just the absolute value of the spread, because we're already, the way that it's figured out, we don't have to use the minus or plus sign because it's already picking a favored or underdog team. And the division game is, the teams are broken up into 3 divisions within 2 leagues, because, teams like Pittsburgh and, Cleveland are always playing each other. They have a much more familiarity with playing each other. There's like some sort of division rivalry, animosity, hatred, whatever you want to call it. It turns out, from my personal experiences, years of watching football, is that, even bad teams tend to do well at home versus their division opponents. And so we put that in as a feature. Whether, and this is, the favored home game is just really just true-false, because we want to know, when we go to classify what we're actually classifying, which is did the favored team win, we just want to put that in there as like, were they favored to win at home. Generally speaking, we train on 3 years of data, and we test on the following year. So in this case, we're trying to test to see how we're going to do. 2014 is the current year, so on any given week, we need to train on the last 3 years of data and spit out predictions for the current week. So here what we have created, we've created like a wrapper. We've created a classifier object where you give it the training data, you give it the test data, you run this is the part that where the scikits learn package comes in. This is the actual object for the classifier. Within the scikits package, there's lots of different classifiers you could use. This is the one that we started with, the logistic regression, but we'll show you shortly how to use different ones. We made our code like modular to the extent where all you have to do is pass in a different classifier and rerun the prediction and the ranking, and it should give you the right answers. And so this is the kind of thing we get. Like, you get a training accuracy on the training data, you get a prediction accuracy on the testing data, and this shows you, so right now, like Alain was saying, is that the current, the line score, which is the spread method, is winning the league. So it's 0 points ahead of the winner, which is good for us because we're going to make some money. Unfortunately, these are in kind of more obscure terminology, but the strategy that we picked, the ENO strategy that we showed before, unfortunately this year is not performing very well. So it's down 41 points. It's a bit like trading on Wall Street. You backtest your algorithms, you think you're going to make lots of money, you turn on the machine, and of course, you start losing money immediately, right?
But we are sticking to the algorithm.
Yeah,
we decided to, under any circumstance, we are not going to change the algorithm until the end of the year.
Right. But what we have done is it gives us an opportunity to like test different classifiers, to test different methods, to see like what we could be doing better, and try to use this as like a research problem. So this is what we get on a weekly basis. One of the the functions that the object has is like, please predict what teams are going to win this week. So this is actually for the current week. It's gave a 92% probability of Indianapolis winning because the line is 14 on them. The Philadelphia, their line is 11. And so you can see more or less the predict probability is sort of similar to the line, but there are some deviations. In this case, San Francisco is favored by 8.5, but the Chiefs are actually ranked higher than that at a 7, a line. The prediction probability is higher than their spread would otherwise indicate.
And you found the link, the Chiefs lost just last Thursday, so
right. So this was a bad pick. And then as you go down to the bottom, any team that is below 50%, it will pick the underdog to win. And I think, in fact, Cleveland, last I checked, was winning, but it's a pretty low probability bet down there. It's only 2 points, so it's not really changing anything one way or the other. And so this is how we, on a weekly basis, come up with what we're going to do. Right. So then let me just go down. So this is an interesting graph that we have here. This is just to get a sense of remember we showed the decision boundary before, between the classifying winners and losers. This is just to give you a sense that this is kind of like a multi-dimensional problem where it's not so easy to visualize the winners. Only the spread is only right about 63% of the time. And this is showing that if you plotted the record of the favored team versus the record of the underdog team, you know, on average, the favorite team seems to win, but there are plenty of situations where, you know, underdogs with like pretty low records beat favorites. You know, there's a bunch of reds in there, which are reds meaning like wins by the underdog team, blues meaning wins by the favored team. And so you can see it's like a kind of a mix-up problem, which is why you might want to go down this route of using the machine learning to uncouple it for you.
This is basically how this is right now. This is live. We have a keep record for tonight's game. So this is Amit. So this is Amit and this is me.
Right.
For tonight's game, Dallas by 5. Dallas is normal. Is the favorite. This is what he picks. And I'm using the strategy. It's basically using the algorithm strategy. So I'm using the dumbest strategy. And Dallas is the favorite. And Dallas, you can see also interesting. You can see what people think about it. The interesting thing is that if you think that the spread is like the benchmark, year to date, up to now, the spread, the dumbest strategy is beating everybody by a lot. Question on here? Yes.
I guess this was kind of like a finance where it's kind of like a technical analysis, because you're using the same data, the same very limited kind of like price data that everyone else is using.
Pretty much.
In hoping to get a better answer. I was curious if is there sort of a kind of like diminishing return, sufficient market sort of thing where you can say that maybe you can't really like beat everyone using the same starting data?
So this is what we thought about it. We have this argument with, we think about the spread strategy like the benchmark,
Right.
like buying the S&P 500.
Right.
We come from finance, so we are pretty familiar with this thing. And what we prove is like what everybody says, like, you know what, why do you waste my time? Just buy the index and live with it. We still think that there might be a way to do it, but we need to find extra information. One of the features that we want to add, that we haven't added yet, is like more technical offensive or defensive. There is this statistics out there called the VOA. I don't know how familiar you guys with Fantasy World. This guy, ProFootballTalk.com, I think that's the site that has offered this statistic called DVOA, which has been very, very accurate for the last like 6 years. And we plan to incorporate DVOA, offensive and defensive DVOA in the algorithm as a features. And we think that might give you some sort of leg up. That could be the case. I still tend to agree with you, because the spread is like beating everybody, and it tends to be always at the top. No, we are not.
You're not.
No. So we decided to basically stick to whatever the prediction was before this one. And because we are using training data up to last year. We don't use new training data.
That would be
That's fine. That's exactly because it means that if I retooling the algorithm, which is true, I can optimize the algorithm, and we thought about it, but it means that I'm incorporating new information from this year that I don't want to pollute my thinking, sort of thing. So I have all the information up to last year, and let's work with that. And we might use it in the future, but we have a good idea of what happened in the past, and that's the reason that we wanted to go that way. Yes, sir.
I was a little unclear on the features you're using, because today's line, is that one of the features?
Yes, it's the absolute line. So
does that dominate the other, variables?
Well, so it doesn't.
It doesn't. So we found that one of the things that dominates is like previous record, like the favorite previous record. For instance, one thing that we saw at the beginning of this year, the Jets beat Oakland in the first game. Everybody had the opinion that New York Jets are not a very good team. The second game was the Jets against Green Bay, and the algo picked the Jets and they almost picked the Jets and very at the top, like, oh, this is great, and the Jets got destroyed. So that's one of the things that we know that there are problems in the algorithm, but we were trying to see how this whole thing works. That was one of the goals.
One question. I'm not clear what you mean by
No. The spread, it says absolute line, number 5. That's the point spread. It's the absolute value of the point spread.
But what you're predicting or what you're training on, is it in last or is it called the spread?
No, we're not covering the point spread. No, the spread, so we're picking games outright. So we only pick the winners. It doesn't matter the spread. We'll see, yes?
Do you have an idea why the previous underdog record is weighted out that, but the previous favored record is not? Is it just
We-
subsumed by?
We are not sure. We have to think about that. There's a lot of questions that we are still unsolved that we need to just go over it.
If you use the final scores as a feedback variable, you might get a better model than user.
If you use the final score, that's a good question. That's definitely a good question.
Another suggestion is keep sort of heated interaction factor.
You're correct, and we were thinking, because this is what I was saying. So this is right. Maybe we'll do something about it, but we chose that basically. It technically slipped our mind, and then we realized when we look at the weights that the game week has almost no effect. So why is that? Because maybe it's loaded in the other factor, and that's exactly the reason. You're totally correct. Yes, sir.
I've seen any models be successful in some kind of momentum factor, like number of wins in a row before the game.
Yeah, so then we thought about incorporating something like last few games, like record.
That is coming. So one of the things that we have problems with is at the very beginning of the season. The only thing that matters to us is like previous year record, and that momentum would be great. And that's if we have that Jets problem, the Jets game, that would have taken care of it. I have the idea, but we didn't. Yes, sir.
You see, just to be clear on this, the way you're using the line, you're saying you're using the absolute value.
Yes.
When you put it in like that, then it's taken away the information.
No, because there is a favorite. There is a favorite record and underdog. Yes.
Right,
So
you basically take the sign.
we take the line for the favorite. That's why we do it. Yes, sir.
So it sounded like at the end when you were kind of discussing ranking the different machine learning techniques, like you went with the model you chose, kind of just looking at end of year total points.
Right.
But did you look at other metrics like, maybe you won that year because you really picked 3 games at 16 points, and maybe the other strategy that maybe it had a larger variance in the points that it was ahead by year, but it was that's right, or there are other statistics the accuracy that is
Right, yeah, so that seemed like the simplest place to start because the point was to try to win the game, but maybe like we look at the accuracy of the test set, as like another measure, right? Like if it's picking 69%.
Yeah, like percent of games that you get right.
Right. Yeah. That's a good suggestion. Yeah, the good thing is we've found it's really good to talk about this stuff because everybody watches, everybody has a thought, and everybody who's a fan has some intuition about it. And so we're trying to figure out what are the things to put in which parts of your intuition are worth putting in and which parts are feel I don't like the Steelers or I don't like their quarterback,
The other thing that
when you just mentioned, you said you know kind of model overrides, but do you do anything in terms of injuries or anything like that?
No, that's another thing that we need to incorporate because it's actually injuries and injury report is a real basically monkey wrench in the game.
Right.
So we don't have a way to factor it in, and then we are done. That's
Yeah.
major thing.
But we just assume that the spread is
We'll take
incorporating,
it over.
right?
That's basically-
Because let's say the Patriots are going to play whoever that's bad, and then Tom Brady injures his knee. Of course, the spread should go down to incorporate that.
But sometimes that's not usually the case.
Right.
That basically the spread doesn't compress enough
As much, right.
to cover that. One thing that basically what I'm going to say. I totally forgot my mind. Yeah, absolutely.
Do you know what Nate Silver does in this space? Because I've seen some of his other bets stuff.
I never seen, so that's my goal. So when we started, we were trying to look for what people have done to pick games. Right. We did massive Google searches. We only saw one other person speaking about this in Google. There is no really nobody has ever tried this at least, or it's not published. Or maybe they're so successful they don't want to publish. I don't know. So I've never seen anyone by one guy that used basically Bayes theory to pick games, and he was very successful with his family. So this has been working for us, and we have 50 people. We have at least the spread method. So we have two strategies going. We think that if we get way more people, we are bound to lose. Because when you have way more people, it's like the whole, you put a typewriter to a monkey, the monkey will type Shakespeare, same idea. Somebody's going to be able to, by pure luck. But still having the spread as a hedge is our goal. That's what we're doing. So, all right, I think that we have, we run out of time. All right, thank you guys.